Hi, Intermediate Algebra. It's Miss Sola here with Unit 1, Lesson 5, Arithmetic Sequences today. Arithmetic sequences. They sound a lot fancier than they are. Okay. Open up to your first blank page, 1.5, Arithmetic Sequences. So I'm going to start with a little vocab here so we kind of get onto the same page. Zoom this in a little bit. There we go. All right. So first of all, what is a sequence? A sequence is just a list. It's a list of terms that follow a pattern. A list of terms that follow a pattern, and that pattern can be multiplying by 4 each time, adding by 4 each time, dividing by 4 each time, subtracting by 4 each time. The pattern is defined. So a sequence is a list of terms that follows a pattern. A term is one unit in that sequence, or one number. Each number in the sequence. And then more specifically, what we're talking about today, the arithmetic sequence. What is that? This is a sequence who, in between each term, there's a common difference, or you're going to be adding something each time or adding a negative, which is the same as subtracting. So the difference, remember, is subtraction. The difference between consecutive terms, consecutive meaning one and then the other, the difference between consecutive terms is called a common difference. Is a constant called the common difference. So like each time you're subtracting by 7 in each term of your sequence, then your common difference is minus 7. So here's an example. All of those words to say, the arithmetic sequence, it's not too jazzy. An example could be like this: 26, 39, 52. Notice there's commas between each of these numbers, and each of these numbers is a term. So what you want to look at, and it could continue, you can figure out what comes next. What you want to notice between these is, if it is an arithmetic sequence, then the difference between each term here should be the same. So notice between 26 and 39, I went up by 13. Between 39 and 52, I added 13. 52 plus 13 is 65. 65 plus 78 is also plus 13. So you can figure out what will come next because you're just going to add 13 to it. Okay, so your common difference here, your D, is 13 because each time it's going up by 13. Now, there's a couple things about the arithmetic sequence that like we can kind of use to define it, because we don't always want to like list every number there is in a sequence, because sometimes they go on for a really long time. So there are two types of formulas that we've got here. One is called the recursive formula. And this one is like using the pattern, what comes next. It usually describes the pattern. To find the next term. Now, this is where it's going to get a little bit, it's going to get kind of fancy looking in terms of math. But so, for example, a recursive formula to find a sub n. And this means, I want to find a different color. There we go. This means the nth term in my sequence. So if I said, find the fifth term in my sequence up here, 1, 2, 3, 4, 5, the answer would be 78. If I said, find a sub 5, a with a little 5, the answer would be 78. What's the fifth term? So nth term is just any one of them, any number. So the nth term is the term before it. So if this was a sub 5, 5 minus 1 then is 4. So this just says any term is the term before it plus the difference. Term before the nth, and this is just the difference. The common difference. Now, this is great. This is a great formula. This says, in order to find the next term, I take the previous one plus d. But with a recursive formula, I also need to know, where does it start? Because with this, like I know I'm going to add 13 to each term, but I don't know, maybe I start at 0. And then I'd have 0 be my first term. But you also have to say, where do I start? So I'm going to say a sub 1 equals whatever it is. And that's your first term. Okay, that's a sub 1. So in order to do a recursive formula, you have to say both things. All right, let's see an example. So for example, -2, 4, 10, 16, 22. I want to write a recursive formula for this sequence. So I need a couple of things. I need what's my first term. I need what's my d. Those are kind of the two things you need for this formula. So in this case, your very, very first term, there's no, that's not trying to be sneaky or anything. It's just the first number in the list, so -2. And then what's my difference? What's happening each time? So it looks like, I don't know, you can start at the very beginning, or you can really go anywhere. I know that a difference between 4 and 10 is 6. Between 10 and 16 is +6. Now I'm seeing a pattern. 16 plus 6 is 22. And -2 plus 6 is 4. So the difference is 6. And this is all you need to write that recursive formula. So it would look like this. A sub n is, sometimes they're going to give you a curly bracket. Like these are all the things included to find a sub n. A sub 1 equals -2. Like the first term is -2. And to find this nth term, you're going to take the one before it plus 6. That's it. Now, I don't love a recursive formula because you have to know the term before it. So if I said, find the 80th term, you'd have to find the 79th term. And if I said, find the 79th term, you've had to find the 78th term. And you'd have to go step by step by step. So in my opinion, the recursive formula is great to help you find a pattern, but the explicit formula is more useful day to day. And it's very, very similar, but the explicit formula is an equation that expresses the exact value of the term in a sequence. Equation to find the nth term. Okay. And it's pretty similar where we're going to I should probably box that too, where we're going to have a couple different pieces to it. This is kind of a big, that's your big formula there for the recursive formula. And here's the explicit formula. A sub n is, and this one's just going to be one line, the first term plus the difference times n minus 1. Now, this is all kind of from y equals mx plus b. I know it doesn't look totally like it, but here's your y. This is actually your b. It's your starting point. Your slope is the common difference that you're seeing each time, and x is like it's moving each time the n. So this is, again, this is going to be your nth term. This one's going to be your first term. This is your difference. And this is just the number of what term you're trying to find. So let's say, for example, let's do 1, 5, 9, 13, 17. Continue. What is the explicit formula for this this sequence? So I'm gonna write the equation here just so we can plug them all in. Plus d times n minus 1. So I'm trying to find a sub n. I'm going to leave that. Equals, I can find the first term. The first term of this sequence is 1. Plus, what's the difference here? What's it going up by each time? It's going plus 4, plus 4, plus 4, plus 4. Right? So the difference is 4 n minus 1. That's it. And then if I said to you, find for me the 20th term, all we're going to do here is plug in 20 for n. So like this is your explicit formula, you're done. But then if I said, find the 20th term, you'd just plug in a 20. So equals 1 plus 4 times 19. Oh, yikes. 19 times 4 is 76. So 1 plus 76 equals 77. So that means if I were to continue this list all the way till the 20th number, the 20th number is 77. Differences can also be negative if you're going down a certain amount each time. Keep that in mind.